In a hydraulic system, fluid flow plays a major role in a system's efficiency, where two main types of flow exist. The first is laminar flow. This type of flow moves uniformly within a system. It moves very smoothly with little to no irregularities, but it's not without its inconsistencies. In pipe, the flow is the fastest in the middle and slowest toward the outside. This is a result of friction forces, where the fluid clings to the inner surface of the pipe. Laminar flow is the most desired flow within a system, and this is because of its predictable and efficient movement, which wastes little energy. However, laminar flow exists at lower velocity. When a fluid's velocity is increased, turbulence can be introduced, which disrupts laminar flow. This is called turbulent flow. Unlike laminar flow, turbulent flow has many irregularities. The fluid molecules often move in a random, chaotic manner, mixing the layers of fluid. This erratic movement requires more energy than laminar flow to move the same distance, and this wasted energy makes turbulent flow highly inefficient and extremely undesirable within a hydraulic system, even if it moves faster. Interestingly, no one flow rate will define when turbulence occurs. Turbulence is the result of high flow rate through a particular cross-sectional area and geometry, where turbulence can be defined by finding something called the Reynolds number. The Reynolds number represents the inertial force of a fluid divided by its viscosity. Turbulence is most likely to occur in bends, filters, and valves, but for a fluid flowing through a pipe, turbulence occurs at Reynolds numbers that are greater than 4,000. However, that does not mean that flow less than 4,000 is laminar flow. Laminar flow exists beneath 2,300, where any flow in between these numbers is considered transitional flow. To create a visual representation of the types of flow, a simple at-home demonstration was created using honey in a sink faucet. As you can see, the honey pouring out of the container has a uniform, clear flow. This is laminar flow. When looking closely, the air bubbles can be seen following smooth and defined paths. These paths are called streak lines, which are easy to follow in steady laminar flow. However, when turbulence is reached as seen by the sink faucet on the right, the fluid flow becomes erratic, and any particular streak line is impossible to follow. This is transitional flow, which looks much cleaner than turbulent flow, but as soon as the flow rate increases, the transition to turbulent flow occurs. As we have seen today, fluid flow is a little more sophisticated than just water flowing through pipes. There are three primary types of flow: laminar, transitional, and turbulent, where laminar flow is desired in almost all hydraulic systems. With the aid of these visual representations, hopefully you have acquired a better understanding of the world flowing around you.